Cylinders. In this section, you will learn how to find the volume and surface area of cylinders, and you will understand the relationship between the circumference of a cylinder and the width of a rectangular piece of material from which the lateral portion of the cylinder is constructed. Here's some useful information about cylinders. A cylinder is made up of two circular bases, one on the top and one on the bottom, plus the lateral portion, which is the curved area that looks like a tube. The important measurements for a cylinder are the radius r and the height h, which is the perpendicular distance from the top to the bottom of the cylinder. Here are the formulas you will need. The volume of a cylinder equals pi r squared h, where r is equal to the radius and h equals the height. The surface area of a cylinder is 2 pi rh plus 2 pi r squared. The 2 pi rh is the surface area of the lateral portion of the cylinder, and you'll notice that the second piece of the formula, pi r squared, is the area of a circle. You have two of them, the top base and the bottom base. Example 1 tells you to unroll the sides of a cylinder to get a rectangle. And the radius of a cylinder is 3, the height of the cylinder is 7. If we unroll the lateral portion, the curved portion, to make a rectangle, what to the nearest integer is the length of the rectangle? The length of the rectangle is the circumference of the circular base of the cylinder. To find that circumference, we substitute into the circumference formula c equals 2 pi r. Since the radius of the cylinder is 3, that's 2 pi times 3, which is 6 pi. Using 3.14 as an approximation for pi gives us 6 times 3.14, which equals 18.84. To the nearest integer, the circumference of the circle and the length of the rectangular piece is 19. In example 2, a cylinder has a height of 4 and a radius of 2. What is the volume of the surface area? We substitute into the formulas. The volume equals pi r squared h, which is pi. Remember, the radius is 2 and we square it, and the height is 4. By order of operations, we work with exponents first. We square the 2 to get 4, and that eventually gives us 16 pi. The surface area is 2 pi rh plus 2 pi r squared. Substituting gives us 2 pi times 2 times 4 for the lateral portion, and then 2 pi times 2 squared for the bases. The arithmetic gives us 16 pi plus 8 pi, which is 24 pi. Sometimes the SAT will ask you to work with variables. In this problem, a cylinder has a radius of x and a height of 3x, and we're asked to find the volume and the surface area. Volume, recall, is pi r squared h, which is pi. We replace r with x and we square it. We replace h with 3x, and doing the arithmetic gives us 3 pi times x cubed. The surface area is 2 pi rh plus 2 pi r squared. That's 2 pi times x times 3x plus 2 pi x squared. This gives us 6 pi x squared plus 2 pi x squared, which equals 8 pi x squared. Next, you will do some practice problems. Pause the DVD after each problem. When you have completed the problem, come back for the answer. In practice problem 1, the lateral area of a cylinder is made from a piece of aluminum with a length of 5 and a height of 7. The circumference will be 5. Find the radius of the cylinder. The answer to practice problem 1 is 5 over 2 pi. Recall that c equals 2 pi r and we're trying to find the radius. We divide both sides of the equation by 2 pi, and that gives us r equals c over 2 pi. Because the circumference is 5, we replace c with 5, and the radius is 5 over 2 pi. On the SAT, you can probably leave it in that form and not have to divide. Practice problems 2 and 3 test your knowledge of how to use formulas. Find the total surface area of a cylinder with a radius of 6 and a height of 10, and find the volume of a cylinder with a radius of 4 and a height of 6. Here are the answers. The surface area is 2 pi RH plus 2 pi r squared, which equals 2 pi times 6 times 10, plus 2 pi times 6 squared. This gives us 120 pi plus 72 pi equals 192 pi. The volume is pi r squared h, but for this cylinder, the radius is 4 and the height is 6. Substituting into the formula gives us pi times 4 squared times 6, which gives us 96 pi. Problem 4. A cylindrical can is cut from a piece of aluminum measuring 8 inches by 10 inches. The circumference of the can is 5, the height is 8. How much aluminum is left over? This work is lengthy, but remember what you want to do is take the original area of the aluminum rectangle and subtract the surface area of the cylinder to get the amount of aluminum left over. The equation for this is length times width for the area of the rectangle minus, in parentheses, 2 pi RH plus 2 pi r squared. The area of the aluminum is length times width equals 8 times 10, which is 80. Now find the surface area of the cylinder. For this one, the radius is 5 over 2 pi. The surface area is 2 pi RH plus 2 pi r squared. This gives us 2 pi times 5 over 2 pi times 8 plus 2 pi times 5 over 2 pi squared, and that will equal 40 plus 25 over 2 pi. If you want the answer written as one term, you must use a common denominator of 2 pi. In this case, multiply 40 over 1 by 2 pi, numerator and denominator. This will give you 80 pi over 2 pi. The answer then becomes 80 pi plus 25 over 2 pi. The amount of material left over, therefore, is the amount of material we started with, which was 80 square units, minus the expression 80 pi plus 25 over 2 pi. Remember that 80 equals 160 pi over 2 pi, and if we subtract, this gives us 80 pi minus 25 all over 2 pi. And remember, when you are subtracting, you're distributing the negative sign, and that's why the sign before the 25 changes from plus 25 to minus 25. In problem 5, a cylinder has a radius r and a height of 4r. You are asked to find the volume of the cylinder and the surface area. This is our last problem in the section, and to find the volume, we substitute into the volume formula pi r squared h, and that's pi r squared times 4r, which is 4 pi r cubed. To find the surface area, we substitute into the formula 2 pi r squared plus 2 pi rh becomes 2 pi r squared plus 2 pi r times the height, which is 4r. That's 2 pi r squared plus 8 pi r squared is 10 pi r squared.